Network Interface Card, NIC, Physical Media Access Control, MAC, address. Think of the Network Interface Card, or NIC, as the physical passport for every host on a network. Whether it is a chip soldered onto your motherboard, a PCIe card in a server, or a USB wireless dongle, the NIC is the hardware that provides the physical connection to the media. To truly master this device, you must understand the immutable nature of the MAC address, how the NIC handles the framing of data, and the difference between half-duplex and full-duplex communication. The immutable identity, the MAC address. Every NIC in the world is manufactured with a unique, permanent identifier known as the Media Access Control, or MAC address. This is often called a physical address or a burned-in address because it is hard-coded into the hardware at the factory. A MAC address is a 48-bit value, usually written as 6 pairs of hexadecimal characters, like 00-60-2F-3B-88-E2. This address is divided into 2 critical parts. The first 3 pairs are the OUI, or Organizationally Unique Identifier. This code is assigned to the manufacturer, like Intel, Realtek, or Apple, so you can tell who made the card just by looking at the first half of the address. The second 3 pairs are the unique serial number for that specific card. Because every card is unique, MAC addresses allow a switch to deliver data to exactly the right machine on a local network without any confusion. The NIC as a gatekeeper, framing and buffering. When data travels across a wire, it moves as a raw stream of electrical pulses or light. The NIC's job is to act as a translator. It takes these raw pulses and frames them into structured packets of data that the operating system can understand. The NIC is also a high-speed buffer. If your computer's processor is busy doing something else, the NIC can temporarily store incoming data in its own onboard memory until the CPU is ready to process it. This prevents packet loss and ensures that your network connection remains stable even when the computer is under a heavy workload. Duplex and speed negotiation. To ensure a successful connection, the NIC must agree with the switch on 2 things: speed and duplex. Speed is simple. It is the rate of data transfer, such as 100 megabits or 1 gigabit per second. Duplex refers to the direction of the conversation. In half-duplex, a device can either send or receive, but not both at the same time. Think of it like a walkie-talkie where you have to say "over" before the other person can speak. In full duplex, the NIC can send and receive simultaneously, like a modern telephone conversation. Most modern NICs use a feature called auto-negotiation to automatically detect the fastest possible speed and duplex supported by the switch. As a technician, if you ever see collision errors on a port, it usually means there is a duplex mismatch, where one side thinks it is full duplex and the other thinks it is half duplex. Security, MAC filtering and spoofing. From a cybersecurity perspective, the MAC address is a primary tool for access control. As we discussed with managed switches, an administrator can use MAC filtering to only allow specific, known NICs to join the network. However, you must be aware of MAC spoofing. While the physical address is burned into the hardware, many operating systems allow a user to mask it with a fake address in software. A hacker might spoof the MAC address of an authorized office printer to bypass security and gain access to the network. Because of this, a strong security strategy never relies on the MAC address alone for authentication. Troubleshooting the NIC. When a computer cannot get online, the NIC is the first suspect. The most important troubleshooting tool is the link light on the back of the card. A solid light means the NIC has link integrity, meaning the physical wire and the electrical connection to the switch are good. A flashing light indicates active activity. If the lights are dark, you know the problem is physical, likely a broken cable or a failed port. You can also use the loopback address, which is 127.0.0.1. If you ping this address and get a response, you know the internal software of the NIC is working correctly. If the loopback fails, the NIC hardware itself or its drivers are likely corrupted. By mastering the unique identity of the MAC address and the mechanics of auto-negotiation, you will be prepared to manage the fundamental hardware that brings every host onto the network. Network Interface Card, NIC. The Network Interface Card, or NIC, is the physical component that transforms a standalone computer into a network host. It is the hardware that bridges the gap between your computer's internal data bus and the transom. ISHN media, whether that is copper, fiber, or the airwaves, for your CompTIA A+ exam, you need to recognize the different forms these cards take and how to read their physical status indicators during a troubleshooting call. The physical forms, onboard versus expansion. In the early days of computing, every network connection required a separate physical card. Today, most motherboards come with an onboard NIC, where the controller and the RJ45 port are built directly into the board. This is efficient and saves space. But it means if the port is physically damaged, perhaps by a power surge or someone tripping over a cable, you cannot easily replace just the port. In professional workstations and servers, we often use expansion NACS. These are dedicated cards that plug into the PCI Express slots on the motherboard. These cards are often much more powerful, featuring multiple ports for load balancing or specialized processors that take the networking workload off the main CPU if a port fails on an expansion card. You simply swap the card for a new one, minimizing downtime for the system. Reading the language of the lights. One of the most common A+ troubleshooting scenarios involves interpreting the link lights on the back of the NIC. These small LEDs provide an instant physical report on the health of the connection before you even touch the keyboard. The link light, which is usually solid green or amber, tells you that link integrity exists. This means the NIC sees an electrical signal coming from the switch at the other end of the cable. If this light is off, you have a physical layer failure, likely a bad cable, a dead switch port, or a disabled NIC in the BIOS. The activity light, which usually flickers or blinks, indicates that data packets are actually moving across the wire. If you have a solid link light but no activity light while trying to browse the web, it often indicates a software configuration issue, such as an incorrect IP address or a firewall blocking the traffic. Advanced features, Wacom LAN. A specialized feature you should be aware of is Wacom LAN, or WOL. This allows a network administrator to wake up a computer that is completely powered off by sending a specialized magic packet to its MAC address. This is a vital tool for after-hours maintenance, allowing you to turn on all the computers in an office to install security updates without having to physically walk to every desk and press the power button. Troubleshooting, the loopback and the driver. When a NIC fails, you must determine if the problem is the hardware or the software. The loopback plug is a physical troubleshooting tool that you plug into the RJ45 port. It loops the transmit pins back to the receive pins if the link light comes on when the plug is inserted. You know the physical hardware of the NIC is working correctly. If the hardware is good but the connection is limited or no connectivity, you should check the device manager. A yellow exclamation mark next to the NIC indicates a driver issue. In the world of cybersecurity, keeping these drivers updated is critical, as manufacturers often release patches to fix vulnerabilities that could allow a hacker to crash your system or intercept your data. By mastering the physical indicators of the link lights and the administrative power of expansion cards, you will be prepared to identify and resolve the most common first-mile connectivity issues on any network.